Hey, howdy, and welcome back. So we'll go ahead and finish up this lesson with a brief discussion of logic errors. And what we'll see here is this is essentially going to be errors that result from errors within the logic that we're attempting to implement. And how we're going to find them is essentially at some point we'll realize we got a snippet of code wrong somewhere. Some erroneous results will ensue, and we'll begin tracking them down to figure out where they are, what we wrote, and how we got the semantics of that statement or sequence of statements incorrect. So an example of this, I'll go ahead and give two. First, let's say we have a function, average. It takes two arguments of type double, A and B. Name should be a lot descriptive, but I don't know, maybe it's satisfactory for this. And this function is going to return a double. And our mistake is in the order of operations. Here we're attempting to return the average of these two double values, and we do a plus b divide by 2. Because we forgot to add the values of a and b together first, what we're really returning is the result of a plus b divided by 2, which is not the average, and this is a logic error. We implemented this incorrectly. So how to get around resolving that? What we needed was the arithmetic to take place first. We can enforce that using parentheses. And then what we'd like to do is go ahead and return the result of that addition divided by 2 to the caller. And that will be what will happen by enforcing the correct order of operations to occur for the calculation of an average, the average of two values. The next one's a little more tricky to catch. And it would be a little trickier if I wasn't so nice and setting this up to really emphasize a point. So let's say we have temps. It has the values of -5, -10, -20. Okay. And all we want to know is, given this collection of data, what is the highest temperature value observed with it, and what is the lowest value? And without putting much thought into this, we simply initialize both of those variables to 0. So we go ahead and visit each element. We go ahead and compare temperature to the highest temperature value that we've seen to this point. If the current temperature is higher, we would go ahead and set the current temperature's value to the highest observed temperature. Likewise, we check to see if the current temperature we're interacting with is less than the lowest temperature we've observed to date. And then if it is, we would go ahead and assign to the lowest temp that temperature. Now, here's the problem with this. Lowest temperature is initialized with 0. Highest temperature is initialized with 0. We will correctly find the lowest temperature with how these variables are initialized. However, we're going to have a problem finding the highest temperature because it is initialized with a value that is outside the range of the data within temps and is actually a value that is greater than any of the values we could possibly observe. So in that case, at the end of this block of code, what's going to happen is highest temp is going to stay at 0, despite the fact that the highest temperature within this data set, temps, is -5. So how do we get around this? It's always best to initialize, say, these min or max sort of variables with something that's actually within the range of data that we're going to be looking at. So instead of initializing these with 0, we could go ahead and say temps dot at 0 and just initialize both with a value that's given to be within the range of values that we'll observe within this vector. And then we'll continue on and we'll iterate through and we'll update it appropriately. But we'll always be comparing highest temp and lowest temp against a value that was within this collection of double values in temp.